Hello everyone, this is your walkthrough for the final check-in number 5 for your summative assignment. So to get started, I actually just want to talk for a quick second about the paper itself before we get into the check-in. So just to let everyone know, in case you weren't aware, for this video, we're going to mostly focus on the actual check-in rather than the paper. But I wanted to let you guys know that there is a template that the professors put together that you can use to sort of outline your paper and figure out what to say and which part of it and everything like that. Because I know in the written version of the assignment, there's quite a bit of information. So I just want to show everyone where to find it. So if you go to your class section, whichever one it is, on the sidebar, you want to go down to module 13 and open that up. And then you want to go to 13.7, which I'm already in, for 13.7 assignment, final summative data analysis assignment. So again, module 13, 13.7. And you'll see a link that says summative final template. And I already opened it, but when you open it, you get to this template that outlines the paper for you, and it tells you like what to write for answering which questions, and it gives you ideas for how to organize it. And I know a lot of people were kind of anxious about writing the paper, so hopefully this helps a lot of you. Okay, I'm going to get out of that now. And also in the same section, you'll see some other files that you're probably familiar with by now, including the data, the overall assignment, the check-in template, which I also have open already. And we're going to obviously be in the check-in 5 tab, and the summative final template, which I just showed you. Okay, so let's start with the actual assignment. Now, the reason I brought up the paper first is that it's possible you actually might want to kind of start writing your paper, or at least have an outline of it before doing this assignment, because that will inform which variables you choose to put in your regression, which we're going to run. So that can save you time from running extra regressions for variables that you end up not talking about in your paper. So I would recommend having some idea of, even if you just like narrow it down to which variables you're going to talk about in your paper, so that you know you want to make sure you have those in your regression. And I guess on the flip side of that, that prevents you from doing your regressions, writing your paper, and then realizing you have to do another one because you just talked about a variable that you forgot to do. So just a quick recommendation. Of course, you can do whatever order makes the most sense to you. So let's get started. Here's the data file. As per usual, I have a shortened version of the data file, so my numbers are going to be a little bit different from yours. Also, as per usual, as you guys have done in I think every check-in at this point, I copied the variables that I'm going to be using into another sheet. And again, I already did the reformatting where I made sure that the heading was just in one cell instead of like 3. I already did that reformatting. If you need a refresher on how to do it, then I would recommend looking at probably the first or second videos that we had. I mean, I do that in all the videos, but I probably would have gone into the most depth in the first couple of them. Okay, so for the example today, I'm going to be using hospital beds, days per decedent, and state. And of course, you will replace that with whichever variables you actually use when you do your assignment. But I will say, I imagine most, if not all of you, are going to want to include days per decedent. And I think all of you are going to want to include state as well. Hospital beds, that's kind of a toss-up. I always just pick that one because it's one of the first variables in the data set, not because there's, necessarily a reason to besides that. Okay, so for this assignment, as you'll see in the template, you're going to need to run a series of simple regressions as well as a multiple regression. Now, for simplicity's sake, I'm going to show you how to do the simple regression with just once with one variable. But you're going to want to end up doing that for all of the variables you end up talking about in your paper besides state. Now, how do we start by doing that? So the good news is at least for the simple regression, unlike the last couple of tests where you have to like, copy and paste the variables into another spreadsheet, this one you can actually just do directly in your sheet that you copied the variables into already. So we're going to open our data analysis tool pack, and friendly reminder, yours is in a different place from mine probably, but you also probably figured out where it is by now. The Y range is going to be whatever variable you're trying to predict. Hint, hint, in your paper, that's pretty much always going to be days per decedent. So I think every regression you run, you're probably going to want to put the days per decedent variable in the Y column. So you're going to want to click in the box, highlight the data, and it should automatically populate. And once again, as per usual, if it doesn't automatically populate, you can just write in the cells, or like into the box, you can write what cells you would have highlighted. For your X range, you're going to do whichever your predictor variable is. And I guess sort of the plain English version of what this means is that in this regression I am about to run, I am trying to predict hospital days per decedent. So my X variable, my predictor variable, is which variable I'm using to make that prediction. So I'm trying to see, does a change in my X variable predict a change in my Y variable? And again, we're trying to predict days per decedent for pretty much all of you for pretty much this whole paper. So we know that's going to be your Y variable. So in this case, my X variable is going to be hospital beds. So I'm just going to highlight the hospital beds column and hope it populates in the X variable. If you included the labels in your highlighting, which I recommend you do because it makes the output easier to read, you want to make sure labels is checked. Confidence interval should be set to 95% if you end up using it. And then from there, I don't think we need to be concerned with the residuals and stuff for the purpose of this paper. You could include that if you were just like interested in looking at it for your own like learning or your own interest, but not a necessity. So pick a cell for the output range, click OK, and here is our output. Now let's take a quick look at how to interpret this. The first thing you want to look for is the significance, and for a simple linear regression, which this is, a simple linear regression is a regression with just one predictor, so just hospital beds. You want to look at the number under significance F, and that's going to be your p-value for the overall regression. And in this case, it's functionally 0, which means it's probably 0.00001 or some very small number like that, because that's a rounded number. And 0 is of course less than 0.05, so this is a significant result. You also want to look at the coefficient. I think what you mainly are going to be interested in is if the coefficients are positive or negative. In this case, the coefficient is positive because it doesn't have a negative sign in front of it. When it's a positive coefficient, that means that for every, whatever amount increase you have in X, you also get an increase in Y. Now, if this had said negative 0.19 instead of positive 0.19, that would be the opposite. So that would mean for every 0.19 increase in hospital beds, you would get a decrease in days per decedent. If that had a negative sign, that's what that would mean. Or conversely, for a decrease of 0.19, you would get an increase in days per decedent. So positive, either they both increase together or they both decrease together. And then negative means when one increases, the other decreases, or when one decreases, the other increases. Works either way. And the actual number of the coefficient tells you the amount of change that indicates a change in the Y value. Okay, so I just want to really zoom in on how to interpret the coefficient in the context of this particular assignment. So the way you interpret this is that since the coefficient for hospital beds is 0.19, for every additional hospital bed that a hospital has, we would expect to see an increase in 0.19 days per decedent. Or in other words, if a hospital has one additional hospital bed compared to a different hospital, then we would expect that their average days per decedent is roughly 0.19 higher. So that would be a fraction of a day. And had this been negative, then it would mean that for every additional hospital bed, we would see a decrease of 0.19 days per decedent. And you can interpret that depending on what the outcome is for your own data, whether it's positive or negative or whatever variables you're using. The next thing you want to look at for the simple regression is the R-squared. Okay, so in the template, you'll see that you want to describe the associations you find, what are their magnitudes. So the associations you find would be from that coefficient we just talked about, looking at whether it's positive or negative, and also just what the coefficient is, because that indicates the amount of change. For what are their magnitudes, that's actually looking at the magnitude of the overall regression. So for a simple regression, we're going to look at the R-square, and the R-square tells you the percent of variance explained or accounted for by the coefficients in the regression. So, and it's given as a decimal, and you can interpret it as a percentage. So this rounds to approximately 0.86 in my particular example. So that would mean that 86% of the variance in the variable you're predicting, so in this case, days per decedent, can be accounted for by hospital beds. And generally speaking, there's a few different people who've proposed different standards for, you know, what's considered a large, medium, and small effect. Generally speaking, it's actually considered to be a decently large amount of variance if it's over about 35, or that's at least what some people consider. I think your book marks it around 0.4, 0.5 for an R-square, which is considered a large effect or a large amount of variance. Generally, if you're in the single digits, so if it's like 0.02, 0.03, that would be a very small amount of variance. And then if it's somewhere in between those numbers I said, it would be a medium. I don't know if you necessarily need to specify small, medium, or large, but just to give you some context when you're interpreting it, that's what those numbers mean. So when you're talking about the magnitude of the effect of the regression, you would basically say R-square is 0.86, so that means 86% of the variance in or the variation in days per decedent can be explained by the number of hospital beds in the hospital. I don't know if that makes sense, because I'm not familiar with the research about hospital beds and such, but that's basically how you would interpret this. Okay, so let's just take one more look at the template. I think we have everything there. Yeah, so you just want to make sure you run a simple regression for any variable of interest besides state. We're only going to cover state in the multiple regression, which we are going to run now. Okay, so I'm just going to delete this output. Of course, obviously you want to save it and copy it and paste it into your template, but I'm not actually submitting this assignment, so I don't have to. Okay, great. So now I'm going to do a multiple regression. A multiple regression is very similar to a simple regression, except in this case, we're actually going to use multiple different predictors to try to predict our outcome variable. Again, as you've probably heard me say 1,000 times by now, our outcome variable is going to be, you guessed it, hospital days per decedent. And we're going to use state as well as hospital beds for the different predictors. Now, you'll have more variables that you're looking at, so you have some freedom in terms of which ones you want to use. I don't think you necessarily need to use all of them, though it may be easier because then you can kind of get it all done in one shot. Or maybe do 2 multiple regressions with half each if you have a lot of predictor variables. But you definitely want to include state because the instructions specifically tell you to do so. Now, as you probably have noticed in this assignment or in others, state is a little bit different because it's a categorical variable. So that means it's going to have to be coded as numbers in order to work in the regression. Now, when you have categorical variables in a regression, there's a very specific way you have to code them. So the first step is you want to take note of how many different values, or I guess different like options there are. Okay, since we already know that the variable you're going to be using is state, it's essentially how many different possible states you could have. And you guys have more than me because you have a longer data set, but in mine, I have California, Massachusetts, and Florida. So I have 3 states. You guys, I don't even know how many you guys have. You guys maybe have like 5 or 6 or 7. So that it's just a matter of knowing how many different states are in your data set. Now you want to take that number, in my case it's 3, in your case it's going to be a little bit more than that, and subtract 1. Now for whatever that number of states minus 1 is how many new columns you're going to need when you're what we call dummy coding the state variable. So I'm just going to write in the 2 columns next to it, state 1 and state 2. Now I'm just going to do a chart to show you. I'm going to write out in a cell to show you guys what we're ultimately trying to do. So we're going to have a code for each state. The code is actually going to be made up in 2 different columns. So one of the states is going to be 1, 0, and the 2 numbers are going to be 0s and 1s. One of them is going to be 0, 1, and one of them is going to be 0, 0. It doesn't matter a whole lot which is which, but basically, however many states you have, you're going to have one of them that's all 0s, and then each of them is going to have a 1 in a different column. If that doesn't make sense to you, it's okay. If you basically follow along with what I'm doing, then it will end up working out for you. So you can just follow the steps I'm about to show you, but that's just conceptually what we're going to be doing. Okay, so actually I'm going to keep that up so that we remember, though it's going to go away in a second, but that's okay. So actually, I'm going to get rid of this because it's going to confuse us. So you guys might remember from the last 2 assignments how we sort and filter our variables. So just like we did for the t-tests and the ANOVAs, you're going to want to go to the Home tab, go to under the editing section, or depending on what version of Excel you have, it's usually kind of like somewhere in the right side of the screen. You want to click Sort and Filter, and then click Filter. Oh, and sorry, first you want to highlight the first row of data. Now, in state, what we're going to do is we're going to individually select each state and then write the codes in state 1 and state 2. So I'm going to start with my first state, and that one's going to be California because it happens to be first. And I'm going to code that one as 1 and 0. And so what I'm going to do is I'm just going to write 1 and 0 in the first row, and then double click the little green thing that pops up. You also could just copy and paste this all the way down, or you could click 1 and drag all the way down. Whichever your preferred method for filling all the cells is going to work. Next, I'm going to unselect California and select Florida. And this one is going to be 0, 1. Great, and that's all set. Then I'm going to unselect Florida and select Massachusetts. And this is the one that I've decided is going to be 0, 0. Now, if there were a 4th state, just to show you guys what I would do, though again, I don't have a 4th state, but I would do another state variable. You also can call these x1, x2, x3. The names aren't actually that important. So if there were a 4th state, then California would actually be 1, 0, 0. Florida would be 0, 1, 0. The 4th state might be 0, 0, 1, and Massachusetts would be 0, 0, 0 if I was going to keep that as the 0 state. So that is how you do it. So basically, each state except for one of them is going to have a 1 in a different column for the however many columns you have. And then except for one state, which is just going to have all 0s. So that is how you dummy code the data. Make sure all my states are selected. So now I'm going to unfilter the data by going back to sort and filter and just clicking filter again. Now, to make this easier for you, when you enter it into the regression, you're going to want to have all the variables going into the regression next to each other. So that's going to be your state 1, state 2, state 3, state 4, state 5, if you have the 5 states, or however many separate state columns you have. Not the original state column with the state abbreviation in it, just the state 1, state 2, state 3 columns. And then I'm gonna, in my case it's just state 1 and state 2. Then I'm just gonna drag hospital beds next to it, because that's going to be the other variable I'm entering into my multiple regression. And it'll become clear that it's just easier if you have them all next to each other. Okay, so I'm going to open my tool pack again. Go back to linear regression. Oh, actually, I think for some versions of the tool pack, this is actually just called regression, not necessarily linear regression, and that will still work fine. But if you pick regression and it gives you an option between linear and something else, then you would pick linear. But if it doesn't specify, then just regression is fine. Like mine, I have linear regression and logistic regression, and I just want linear. But if it just says regression, no worries, that should be good. Okay, so once again, our Y variable is going to be hospital days per decedent. And then our X range, we're just going to select highlight all 3 columns with the variables that I'm putting into this. And you'll probably have more than 3 columns, but I just have 3 because it's an example. Same settings as before, make sure labels is checked. The confidence interval usually is set to 95. And then I'm gonna just pick an output range or, an output cell. Okay. So now let's look at our output and how to interpret it. So this time, again, you might want to start off by looking at the significance of the overall regression. But what's actually more important than that is the significance, or the p-value, for the individual predictors. So again, or not again, but just as an FYI, the intercept here is the y-intercept. That would be the typical B0 in a regression equation, or just from your algebra line equation that you might remember from, back in the day, back when at some point in your schooling days growing up, you might have encountered y equals mx plus b. This would be the b. And then the coefficients would be the numbers in front of x1, x2, and x3 in the actual equation. So you'll see here, hospital beds is in scientific notation, and it's a very, very small number. It's something to the negative 60th, or it's like practically 0. Now, state 1 and state 2 actually are not significant in this equation. So the point of looking at this output is to look at whether each individual predictor is significant or not. And the predictors are going to be the rows after intercept in the output. And one of the specific things that you're meant to look at is whether there's a difference between the predictor you entered in the multiple regression and when you entered that same predictor in a simple regression. In this case, there was not a difference, but I entered hospital beds in the original simple regression I did. Sometimes when you use a predictor only on its own, it comes out significant and it shows to have a large effect. But then when you start adding other predictors in, it becomes insignificant and the magnitude may become smaller. The reason for that is that when you have a multiple regression, in the equation, basically the effects of each predictor kind of account for each other. So if, say, the state ones were significant and the hospital beds was not significant in this version, that might imply that the effect of hospital beds is actually accounted for by state. So what looked like was an effect of hospital beds was may actually have been due to something else. But again, that's not the result of this. That's just how you would interpret it if you did find a result like that. Okay, so we know, so it looks like state here was not a significant predictor because both of the state variables have p-values of greater than 0.05. I'm just going to quickly run down on how to interpret this in case they do come out significant for some of you. Basically, each state, whichever state was coded as 1 in that column, so state 1, California, was coded as 1, the coefficient will tell you the amount of change and whether it's a positive or negative change for that state that state predicts in the outcome compared to the other states. So again, we don't really need to interpret these when they're not significant, but if they were significant, like if this was significant, then I would say that a hospital a hospital in California is likely to have, or I guess maybe being in California predicts an addition of 0.26 when you round days per decedent compared to states from Florida or Massachusetts. So if it were significant, that would be my interpretation of that. And then for Florida, or state 2, Florida was coded as 1. So again, if this were significant, which it's not, I would say that a hospital being in Florida is associated with a 0.21 increase in days per decedent. But again, and I know the interpretation doesn't really make sense, and that's, I think, in part because these aren't significant, so you actually don't need to interpret them, but just as a, or actually, sorry, because Massachusetts is a state that was coded as 2 zeros, this is like the interpretation of comparing the state to other states, it's mainly applicable to whichever other states coded as 2 zeros, which we call the reference group. Again, I'm not going to get too much into this because it didn't really come out significant, so it's not going to make too much sense to go into, but just as a note so that you guys have a rough idea of what this means. Okay, so I think that covers running the regression, looking at the level of significance for each of the independent variables, which is the p-value in the regression table. And then next we want to state and interpret the magnitudes. So part of that is talking about like the actual number of the coefficient. The other part of it is the adjusted R-square. The adjusted R-square is similar to the R-square, but it's more appropriate than R-square for a multiple regression because having multiple predictors in a regression can actually, for mathematical reasons that we don't need to get into right now, artificially inflate the R-square. So sometimes it will make the R-square bigger than it actually should be for the overall regression. And again, don't worry about why or how. That's very much beyond the scope of this class. Just something to know that it does. And the adjusted R-square accounts for that inflation. So for a multiple regression, I always recommend looking at the adjusted R-square. But you interpret it pretty much the same as the R-square. It's telling you the level of variance accounted for by the predictors in this equation. So yeah, I think that covers everything you guys need to know. So yeah, we have the significance. We talked about the coefficients, or the significance of each coefficient, the magnitude, and the adjusted R-square. Great. And then comparing the multiple regression to the simple regression for each predictor that you enter. Great. So that covers everything. I have one very minor note about the paper that I just wanted to make everyone aware of. In the previous 2 check-ins where we did t-tests and ANOVAs, we did a lot of coding variables into high, medium, and low. Well, I guess first of all, you don't do that for the regression. You absolutely don't need to, and it will just make your life more difficult and actually will make the regression less accurate to read. But when you go back to the t-tests and the ANOVAs, when you're writing your actual paper, you do at some point, if you use that data, you want to make sure you indicate like what your cutoff points were for high, medium, or low, or just high and low if it was a t-test, and why you chose those variables. So, you know, if it was like the median level or if it had to do with percentiles, you just want to maybe add like a quick sentence explaining your reasoning for the cutoff points you did, and of course explaining what the cutoff points are. Great, so that is your final check-in. Good luck writing your paper, and I am here if you have any questions about data interpretation. Thanks, guys.